Yahoo! Welcome back to Math and Silly Hats, Episode 2. Today we're going to be talking about congruence. So identifying congruent shapes on a grid. Well, without a grid, because that'd take a whole lot of time, a whole lot more time than I'm willing to dedicate to that. But I am willing to dedicate my silly hats to you. So to understand congruence, first we have to define that. What does it mean to be congruent? Well, if we click on our ALEKS definition for congruent, you'll notice it's underlined. It has a hyperlink on it. It'll give you the definition. Figures with the same size and shape. So I have here ABC, which I've used to make all my ABCs. It's a triangle. Now, some of you may say, well, are these the same? Well, the short answer is, if you could use the same piece of paper or other representation to show the two shapes, no matter how I angle this, rotate it, reflect it, it's still the same size, same shape. It's still a right triangle, yeah? Okay. So we have a few ways we can transform our figures and still have them be congruent. So let's start with a translation. A translation is simply when I move this figure up, down, left, or right. So we can see triangle ABC here is still congruent to triangle ABC. It's changed places, but the angles and the sides are all still congruent to the original. Second transformation we can do is a rotation. So rotation is where we rotate this whole figure about a point. I've chosen point B, so I'm just going to rotate this here 90 degrees. And you'll see that's obviously still congruent to the original figure. Now, point B is in the same place as B prime. That would be the post image after the rotation. But you'll notice point A was up here and A prime is here. It's okay, they don't have to be in the same orientation as long as it's the same size and shape. And you can see as we rotate that, it doesn't change size. Now, a reflection is reflected across a line called the mirror line. So here we could see if we had our triangle here and we reflected it, so it's kind of looking in a mirror. It could look at this mirror and its image would be as far away from that mirror as it is. So if it's standing, say, 1 inch from the mirror, its image is going to be also 1 inch from that mirror. And obviously you can see these still are congruent. They still have the same size and shape. And then finally, one that will not preserve congruence. Another transformation we can do is a scale factor. We're going to enlarge or shrink this. So I have my pre-image here before the transformation of a scale factor. You can see I've got a small right triangle here. And then in red, I've got a significantly larger triangle. Now, these are not the same size, obviously. This is significantly smaller. But you'll notice some of the properties of this triangle are still preserved. It's still a right triangle, so I can show that the angles here are all the same. I can obviously see angle ACB is congruent to angle A prime C prime B prime. So the angles of the large and the small triangles are still the same, but obviously it's not the same size or shape. So this is what we call similar figures, though they're not congruent. Now I'd like to do some guided practice problems on ALEKS. Alright, so ALEKS is just going to ask us whether or not each of these figures are congruent. Well, we could hopefully at this point not only say whether or not they're congruent, but also say what type of transformation took place here. Here it looks like these are both rectangles, but there's certainly a transformation that did not preserve congruence. This could be moved over here, but this only occupies 2 squares of space. This is going to occupy 12 squares of space. It's significantly larger, so these two are obviously not congruent. Here we have, again, a circle, another circle. They look similar, but this circle is significantly larger. So we did not preserve this size, even though the shape may have been preserved. Those are not congruent. Again, we have 2 shapes that are actually quite different here. This appears to be an isosceles triangle, whereas this is a right triangle. So neither the size, this is significantly larger, nor the shape, this has no right angle, this has a right angle here, were preserved. So this is not congruent. And then finally we have 2 trapezoids that seem to just have been translated, moved it left or right. They appear to have all the same angles. This bottom side is 4 units long. Bottom side is 4 units long. The top is 1 unit. Top is 1 unit. So these two are congruent, and if it asks for transformation, we just translated these from the left to the right. So we've seen here today, we have 3 different types of transformations that will preserve congruence. In other words, we'll have the same size and shape of our figure before and afterwards. It can be rotated, it can be moved to the left or right, or it could even be reflected, but it's going to be the same size and shape. Transformations that do not preserve congruence would be a scale factor, or just like on your phone, if you were to stretch this like some kind of crazy Instagram figure, that would obviously not have the same angles nor the same size, so that would not be a congruent transformation. Hopefully you found this helpful. Have a great day, everybody. Bye-bye!